This is section 6.1. We are going to be graphing polynomial functions. The homework is 1 through 15. Suppose that we have y equals x squared. We did this in the last chapter. If we have y equals x squared, that's called a quadratic. And the graph looks like this. The graph of a quadratic is a parabola. On the other hand, if we have y equals negative x squared, that takes the graph and it flips it upside down. So it's a parabola, but it's upside down. In this section, we're going to be graphing what we call higher degree polynomials. An example would be y equals x cubed plus 4x squared minus x minus 2. Notice the highest power of x is a 3, which is larger than 2. Another example of a higher degree would be y equals 2x to the 4th plus 3x cubed plus 2x squared plus 3x minus 1. Again, notice that the highest power, which in this case is 4, is larger than 2. So we call these higher degree polynomials. By the way, the degree is the highest power of x. So this polynomial right here we would say has degree 3, and this one we would say has degree 4 because of the 4. The graphs below are graphs of polynomials. The graphs will have high points and low points. We call those turning points. So if you look at this graph right here, notice I'm going, let me erase that so you can see it a little bit better. So I'm going to start down here and I'm going to go up and I'm going to turn. This point right here is called a turning point. It is also called a local maximum. So I'm going to go down, I'm going to turn and go up. So this point right here is a turning point, and in this case it's called a local minimum. Graphs of polynomials are what we say they're snake-like, they go up and down. So right now we want to figure out how many turning points there are. If we look at graph A, so we go up, turn, down, turn, and go up again. This would have 2 turning points. Graph A has 2 turning points. If we look at graph B, we go up, turn, 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 and go up. So I have 1, 2, 3, 4 turning points. C would have 1, 2, 3 turning points. And graph D, 1, 2, 3, 4 turning points. The number of turning points is determined by the degree of the polynomial. So if I had a polynomial with degree equal to 10, degree equal to 10, then it's going to have 9 turning points. If I had degree equal to 600, then I would have 599 turning points. It is possible to have less turning points, but you're never going to have more than that number of turning points. So let's take a look at example 1. We have f of x is equal to x cubed plus 6x squared plus x minus 1. We need to figure out the maximum number of turning points. So we look for the degree, that's the highest power of x. In this case it has degree 3. So 1 less than 3 would be 2 turning points. I would have at most 2 turning points. Example 2, f of x is equal to 2x to the 10th minus 8x to the 4th plus 3x. The degree is 10, highest power of x, so 9 turning points. I want to talk about what we call end behavior. End behavior is what happens on the end. So with the quadratic, on the end, on the right end, this quadratic's going up, and on the left end, this quadratic is also going up. With a quadratic, y is equal to x squared, the end behavior goes up on both ends. In fact, any parabola, so it doesn't have to be just y equals x squared, will have the same shape as long as the a, this number right here, is positive. If a is negative, then both ends are going to go down. It turns out that if the polynomial function has an even degree, so when I say even degree, I'm talking about y equals x squared, y equals x to the fourth, y equals x to the sixth, y equals x to the 98th. As long as it's an even degree, it's going to have the same end behavior. Both ends are going to rise or they're going to fall depending on whether a is positive or negative. It's possible to have turning points in between the end behavior arms, but it's going to be, in general, either a U or an upside down U, with turning points possibly in the middle. So, as long as the leading coefficient, that's the a, is positive on the ends, my graph is they're going to go up. Both of them are going to go up. In this particular graph, how many turning points do we have? So 1, 2, 3 turning points. So this would have, if it has 3 turning points, then it would have degree 4. So it's going to be y equals x to the fourth something something something. But you know it's going to have degree 4 because there are 3 turning points. And both ends go up. On the other hand, if the leading coefficient is negative, if a is negative, they're both going to go down. How many turning points? We've got 1, 2, 3 turning points. 3 turning points means a degree 4, so y is going to be equal to x to the fourth of some nature. There could be other stuff there. Since it's going down, this number has to be negative. Now, if it's an odd degree, it does something different. End behavior, one arm is going to go up, one arm is going to go down. What we look at is the leading coefficient. If it's positive, then the right side will go up. Positive leading coefficient, the right side will go up. If the right side goes up, then the left side must go down. On the other hand, if you have a negative leading coefficient, the right side is going to go down. For an odd degree, the arms are going to go in opposite directions, so the left side will go up. As a review, leading coefficient is positive, the right side's going to go up. Odd degree means the opposite arm is going to go in the opposite direction. This one has 2 turning points, which means degree 3. So it's going to be some sort of x to the third. And this would be a positive number. Don't know what it is, but we know it would be positive because the right side is going up. If the leading coefficient is negative, that means the right side is going to be going down. Arms are going in opposite directions. Makes it odd. Number of turning points. 1, 2, 3, 4 turning points. So that means it's going to have degree 5. So y is going to be some sort of x to the 5th. And since the right side is going down, that's going to have to be negative. I'm going to stop here for now. I'm going to do part 2 of the video using the next slide. So we're going to stop here for now.